Hello everyone, Federico Razzoli here, and I will talk about MariaDB Connect storage engine. So who am I? I am a database consultant specialized in MariaDB and MySQL ecosystems, and I recently started this new company called Vetabase. So let's talk about Connect. Before explaining what Connect is, let's see what a storage engine is. Well, the thing is, MariaDB knows very little or nothing actually about how to write or read a row, or write indexes, caching data, and so on. So these functions are implemented in special plugins types called storage engines. If you know nothing about storage engines, well, whenever you create a table, it is of type InnoDB, which is the default storage engine, and it is absolutely a reasonable choice because InnoDB supports all the reasonable features, and its performance are ideal for the generic use case. Still, there are reasons to use different storage engines sometimes. So, an interesting thing is that actually when MariaDB asks, okay, Mr. Storage Engine, please read this row or write this row, actually Mr. Storage Engines could do anything. MariaDB will never know or doesn't even care. So for example, Black Hole Storage Engine writes absolutely nothing. The data you insert in a black hole table simply disappears, as the name says. Sequence returns sequences of numbers. Spider is used to read and write data remotely, and it's used basically for sharding data over several servers. And CSV, for example, handles a file of type CSV on disk. So let's see Connect. If we run a simple query, we can see that Connect describes itself as a storage engine for management of external data. This means that it is conceived to read data from external data sources, understand them, and then do something with this data, as if they were regular SQL tables. So, and actually it's called Connect because it connects MariaDB to some other data in some other form. But other form can mean many things depending on the table type. So basically there are table types that read data from remote DBMSs. It could be MariaDB, but it could be also something else. There are table types that use data from files written in various formats, like CSV, but also JSON, XML, or many other formats actually. There are special data sources. For example, in Windows you can even see the information about available network interfaces. You can see this information as a table. And there are table types that make some kind of data transformations, and we will see at least one of them later. So we have just half an hour, we don't have centuries, so I can only talk about some specific things. We will focus on file-based tables, and then we will start playing a bit with Connect. So file tables can be of two macro types. Okay, they can be inward or outward. I'm using these terms as they are used in the documentation, even if I believe that they should actually be swapped. Okay, but anyway, basically a table is an outward table when we specify the file name clause, as in this simple example. Okay, we are creating a very simple table and we specify a file name. This means that we are going to use a file that already exists, and for this reason the file is considered somehow holy, okay, because it comes from the outside and we cannot ruin it somehow. Okay, so this affects the way alter table is performed. If we drop a column, for example, what will happen is the column will disappear from the table, but not from the underlying file itself. So what changes is if we can see that information or not, but the information is still there. If a table is inward, well, the underlying file is modified instead. So an inward table is a table based on a file, like in this example, because we are still using the table type CSV. So a CSV file will be created, but we will not use an existing CSV file. Okay, so we cannot specify a name for the file, but this is not a big problem because we can easily guess it. So the file name is the table name dot a meaningful extension, in this case CSV. If we are not sure about the name, we can run show warnings after create table, and we will see a warning which tells us the name of the file. Here I show a regex to take the file name from the warning. It's easy because it's simply the last word. So an interesting use case for Connect is the following. Receive data in a certain format that we understand, make some changes that is easy to make in SQL. So these are two trivial examples. For example, we only specify some columns, or we specify a group by, and then we export the result of this query in some in the same format or in another format as we prefer. So how to do it? Well, in the simplest case, we create an outward table. We use create table select to basically run the select that we want to run to make some transformations on the data and save the result in a connect table, and then copy the file elsewhere and then drop the table. Or if we want to make some more complex transformations, we can create again the outward table, run create table for the intermediate data we can use in InnoDB. Then we can add indexes. Then we can make some transformations on the intermediate data, and then we use create table select, and we can also specify well, of course, engine connect and the table type, and probably some other options to specify the format that we want to use. Like, for example, in this case, we specify that the separator character is a tab, and first line is not data, but is the names of the columns. And then, of course, we copy the file elsewhere and we drop the table. If we have an existing table and we just want to export it in some format supported by Connect, well, this alter table is probably the most efficient way to do it. Just keep in mind that this is an inward table, and therefore we cannot specify a file name and a path. But this is not a big deal, just you will need to copy the resulting file to some other place. So, enough talking, let's try to read some Apache logs. We will use a very small sample, which is basically a sample of the Apache error log for database.com. The IPs are scrambled, so you will not see any secret. So here's some lines from the file, and okay, basically some considerations. The log uses a precise machine-readable format, but it's not very regular. It's not as easy to read as CSV or JSON. Okay, so we cannot simply use table type equal CSV and expect it to work. Okay, we will have to do something slightly more complicated, because we will have to define a mapping between the data written in the file and the columns those data refers to. Well, we don't care about all the columns. So, okay, this is a line, so this is the list of information we care about, so the IP, time zone, and so on. As you can see, between the various data there are some strings that are fixed. They are the same on all rows. So we will just have to communicate these strings to connect. So here's how we create the table. I will not explain every single line because it requires too much time. So, of course, we specify engine connect, then we specify table type FMT, which stands, I suppose, for format. We specify a file name with a path, because I think it's better for most cases. I mean, you don't want to simply put the Apache log into MariaDB data directory. It would be quite dirty and dangerous. And, of course, in the create table we have a list of columns, and you can see that for each column we specify field format clause. This is not MariaDB SQL. This is an option which is only understood by Connect. The most important thing to notice is these are like templates, right? Where we have % followed by another character. So %n is just a market. It means here the data that needs to be in this column begins, and then the next n means here the data ends. And then inside these two markers we have %s or %d, or we can have also something else. Basically it is the same format used by some C functions like scanf. And then before or after these markers we can have a fixed string. Okay, so it's easy to make mistakes while doing this. So unfortunately it's not very easy to find out what you did wrong. So the first error here is what we get if we probably don't specify a full path, or we specify maybe a wrong path to the file. And the following error message is what we get if field format is not correct for a certain column. It's not very informative, so if you get this error you will need to work a bit to find out what was wrong. So if we select a line from this data, we can see the result, and it's mostly okay, but you can see it's not perfect. So the time column includes a beginning square bracket, the time zone column includes a final square bracket, and protocol includes a double quote. These characters shouldn't be there, but basically I tried to exclude them, and I didn't succeed. After spending some time on it, I looked at the documentation and I saw they actually had a very similar example, but they also used some sort of workaround. Okay, so it's like, for some reason, we cannot have a perfect table for this kind of data. So instead of wasting more time trying to get a perfect result, which I don't know if it is possible, we can do this. We can have some virtual columns which basically use some SQL expression to drop a character at the beginning of the string, like in the first example, or at the end of the string, like in the other examples. Probably it is not really necessary, so we can have some additional trailing characters, and we don't necessarily need to care about it. But if we want to have complete data, we can use this trick. So this query shows that basically this works well. Now let's do some analysis on the Apache log file. Okay, of course, as you can see, we can run at this point any SQL query. So, for example, we can group data by a certain column. But what if we want, for example, to pivot the data? MariaDB does not support syntax to get pivoted results. Okay, but we can use a special connect table type which is called pivot. So before doing it, some forward. Connect tables that transform data in some way basically establish a connection to MariaDB just like any other client, and run some queries, and then get the results, and then transform the results in some way. But in order to do that, they need to use a username and probably a password. So it is a good practice to have a MySQL user in our databases. It exists by default because it's created by MariaDB install.db tool. So in this slide, you can see the create table that we can use. We specify table type pivot. We specify the name of the base table, which is weblog in this case, and usually the table is in the same database as the new connect table, but if it is not, we can specify a database name. Then we have option list, where we put, first of all, the credentials to use to connect to MariaDB and get the data from the base table. And here you can probably see why I suggest to use MySQL user, because it uses by default the Unix Socket authorization plugin, and as a consequence it doesn't require a password because the authentication is actually done by the operating system. In this case it works because MySQL is the Linux user used to run MariaDB. So we don't need to specify a password, which is very good, because if someone inspects the table structure, well, they will see the passwords. I mean, they will see the complete option list. Okay, so the next two options are what actually define how the pivot works. And basically the pivot column is request type, and the function we're using is count, but we can actually use any other aggregate function like sum, AVG, or anything else. And you can see the result here. You can see that the values for the pivot column are, for example, get and head, and they became columns. But this result is a little bit inconvenient and almost unreadable. And to make things work, we cannot even specify select request type and then get and then head, because these special columns are created during the query execution, and if we mention them in a query, well, the query will simply fail. This happens because a pivot table type is meant for tables where we only have the column to be pivoted and aggregate data. This doesn't work usually for a log, but instead what we can do is to create a pivot table which is based on a query and not on a table. So in this slide you can see what we are doing. I will not show the whole create table again because it's a waste of time, and I will only show what's changed. Okay, the option list is shorter, and we add a source def clause, which basically contains the query to execute. And the query is very simple, is just a group by request type. Okay, so basically when we query the pivot table, each value from request type column became a new column. Okay, and the value is just the count as requested by our query. This is a very simple pivot table. We can do much more interesting things with pivot tables, but probably not in the case of a log, at least. Maybe we can, but I'm really not aware. But anyway, there are also other transformations that you can do with Connect. So you can see the other transformation here. So the occur table type basically unpivots the columns. So basically it turns columns into basically values of a single column. It is the opposite of pivot. Xcall turns string lists, for example, comma separated, into multiple rows. And table, basically, it's defined on a set of tables, and it allows to use them as a single table. So this was basically the last thing. What did we leave out? Almost everything, because the topic is huge. Connect really supports a lot of stuff, and we just played a bit with an Apache log. So we left out the other file formats like JSON, XML, HTML tables, fixed length files, which are familiar, for example, for COBOL programmers. We left out compressed tables because we could have read the Apache log in a zipped format if we wanted to. We left out the magic we can do with custom formats, so for logs in strange formats, the connections to remote DBMSs, MySQL, ODBC, JDBC, MongoDB. We left out that we can query remote REST APIs, which is not really simple because you will have to write some code for this, and it only works on Windows, but still you can do if you really need it. And we left out more stuff. So to make you not too sad for this, I'm including two final hints, which are, first of all, build proper indexes where possible, and then if your queries on Connect are still slow and the files you are working with are big, you can increase Connect work size cache, because it's the cache used by Connect, and if the size it is by default something like 60 mega. But if it's not enough because you are working with big files, you should probably increase it. And of course, if you have to do elaborated queries, well, also consider taking the data away from Connect and move them to some InnoDB table. Okay, so this was the last slide. So thank you everyone for attending. I hope that the talk was useful, and this is question time.